Hello everyone, welcome to our video on 2003 Junior Cert Higher Level Question 4 on developments. In this question, you can see that the object presented, the elevation and end view of a container based on a pentagonal prism are shown. The container encloses a snooker ball which is tangential to all surfaces. I'll just zoom in a little bit so we can have a closer look at this drawing. Now, so I was just having a quick read through the question. Part A says draw the given view, so just the elevation and end view exactly as given. Part B, show the projections of all points of contact between the ball and the surfaces. It's all surfaces of the container. Now, projections means show in every view, not just in one view. And part C then is draw the complete surface development of the container. First thing to realise, I suppose, is, and a little sketch here that I just did before the video really helps. First thing to try and start to understand is how many surfaces are there. So what I've just colour coded mine. What we have is here is the orange surface, just like in my little 3D sketch over there. There's the orange surface, which is an edge view here, that side of the object, working up to the top and down. And as we're looking, it's in front of us here. We have the overall blue surface is this front one right here. Now it appears there in the elevation as a regular pentagon, and of course it's not a regular pentagon. The blue surface is not a regular pentagon anyway. The back of the object is a regular pentagon, but the blue one is not. There's the blue surface right there. So it's much longer. It's kind of an elongated version of a regular pentagon. The green surface down low, well, that's going to be down here, working down towards the ground, which is going to be here. Yeah, with the green one. And we're going to need some more colour because there's a lot more surfaces, of course. We have this yellow one here to the back, which I can't really shade in. It's the one there at the back of the object, right there. There's a purple one here down to the ground as well. There's this brown one here, which is on the ground. The light brown, the base of the object that sits on the ground. And finally, I'm nearly running out of colours. We go with this. What did I go with? I'm just going to go with actually pencil, just a shaded surface. So the whole back of the object itself, which is a regular pentagon right there, that is our last surface. So there's quite a number of points of contact. The snooker ball, or the sphere, that fits into this packaging touches every surface. So if we just start looking how many unique colours we have, well, first of all, we have the 1, 2, 3, 4, 5 surfaces of the pentagon. So that's 5 unique colours. Then we have the pencil shaded one here to the back is 6, and we have the blue sloped front 7. So there are 7 points of contact in the elevation and to show in the end view. So that's just getting into the terminology there of part B. Show the projections, meaning in all orthographic views, projections of all points of contact between the ball and the surfaces, not just any one surface. It's all 7 in this case, all 7 surfaces. Now we might as well get started. To start this drawing, I'm going to be working maybe up high in my page. I want to leave a bit of space down below. I'll start up near the top of my page. That's 25. There's probably going to be another 7 or 8 mil maybe above it there. So that's 25 and 50, and I'm going to come down about 65 mil from the top of my page, and I'll have my XY line, and I'll keep this elevation up in the left corner. So let's get started. So as I said, from the top of the page, I'm going to come down. I'll actually, yeah, 65 is probably good for this. I'll draw my XY line. On the left hand side, I'm just going to come in about 80 mil. And I'm going to measure up along that line 25 mil. And the first item I draw is that 25mm circle, which is the snooker ball. It is the elevation of the sphere, or the snooker ball. So there we go. So there's the elevation drawn. I'm not going to move on to the end view. I'd like to get the elevation finished now. What I know is that if I look back at this question again, I have a pentagon circumscribing a circle. Or if I put it the other way, the circle is inscribing the pentagon. We have to go back to our basic understanding here of tangents and normals. And if that green surface right there, which we know to be an angle of 72 degrees, if that green surface is a tangent to the circle and it's at 72, then the normal that comes out here to find our point of contact has to be at 90 degrees to the tangent, so it's going to be 36 degrees. We can go and we can draw our horizontal line and go at 36 degrees, but what I'm going to do is I'm going to make things a lot easier for myself and use my adjustable set square. So what I'm going to do now, I'm going to set my adjustable here up along, and I'll make sure I'm not on the 68 degree mark below the 70. I need to go up to my 70, 71, 72 right there. I'm going to go up to my to my elevation that I've just started, and from the center of the circle I'm going to go out at 36 degrees and then up at 72 degrees. I'm going to do the same to the left side, out at 36 degrees and up at 72 degrees. What I've just done is I've found 2 points of contact for 2 of my faces. Inadvertently, when I've done 2 points, I've also found the length of the side of this pentagon. That is the true length of the side of each of the sides of the pentagon, so I can step off here. I can step off here. While I'm here, I can also I'm going to put this really light now just to make sure, as a verification, we should end up on the exact same point which I just did, perfectly hitting the center line of the object. I know that the top angle is going to be 36 degrees. I also know that I need a normal. So this is what I'm going to do. Instead of using my adjustable and setting the angle again, this is what I'll do. I'm going to, that's the angle of the surface. If we slide back, I can find the angle of the normal, which gives me a point of contact, and I'll come over again and I'll actually heavy in that surface as it should be. Now that's one more surface there, and the final one here, which is our yellow one up the top, from the top down, I'm going to just draw it really light. That's only as a means of setting my angle for a normal. And I'll go back in, and if I see that it's all right and it's all perfect, I can go ahead and draw it heavy, just like that. So there's the pentagon. Little bit of thinking going into that one. In one step there, just right now in that little construction, I have found 5 points of contact and 5 surfaces. Oh, there we go. What I'm going to do is I'm going to very lightly just drop in a little label, POC, beside each of my points of contact. So, 5 points of contact shown. That's it for the elevation. There's nothing else to draw. I will have 2 more points of contact to come back. As I said, there's 7 points of contact in each view because there's 7 surfaces. But I'll get back to that. I'm going to move over now and start drawing my end elevation. I'm going to project across everything I have. And what do I have? I have the base of the object. I have the center of the circle, of the sphere I should say. I have this intersection between yellow, purple, or orange, green, whatever you want to call it. We'll go with orange and green because they're the visible surfaces. So I have that intersection, and I have the top of the object right there. So I project across all my heights. I'm then going to I'll see what I have, because it just initially appears like there's very little information given here. It looks like there's something missing. We'll find out if there is or not. So, center of the sphere is first. Intersection is second. And the top of the object is third. Leave whatever space you are used to leaving between the views. So between this one here, which is the far right hand side of the in view, I might just go ahead and leave 15 mil. And the left side, which is my pencil shaded side, that's the color coding I'm giving it, is there. All I know from here is that basically the sphere touches that shaded surface. So I know that the center point of the sphere must be 25 mil away from that shaded surface. So I'll drop that in. So from the center of the sphere, touching the shaded surface, I can go ahead and mark 25. I'd like to just make sure I'm always accurate here, so when I'm going to draw on the circle, I want to make sure it touches the base point and that left point. Always verify before you draw. You don't want to go rubbing something out if you can avoid it at all. That is pretty good. So I can go ahead and draw in that sphere right there. There we are. And I should have done this last time. I always draw the circle first, and ideally, while I'm in the same center point and in the same spot, drop in your hidden detail on it. Never ever ever freehand in these hidden strikes on a circle. It just doesn't look good. There we go. This stage, I'm back to the drawing board, I'm back to my question again, and I'm looking at this. The blue surface is pitched up at an angle of 60 degrees. Now, just like these previous ones, we talked about a 72-degree angle being our tangent and a 36-degree being our normal. A 60-degree angle on a tangent means a 30-degree angle for a normal. So that 30-degree angle right there is what we need now. We need to take that up at 30 degrees. We need to find our point of contact. Then we need to pitch up our blue line there at 60, which represents the sloped front surface of the object. Now, 30 degrees up from the center point to our point of contact, and from that point of contact 60 degrees down from top down to base will be our tangent angle for that front blue surface. I can draw in the top of the object, I can draw in the base of the object, and I can differentiate between the orange and green surface in line with what we had in the elevation over here. So that is there to there. I'm going to stop for a minute now, and I'm going to have to I'm going to add a little bit of shading into my surfaces, very very lightly over them of course. I think it's going to help maybe going forward. I wouldn't do it in an exam scenario, but just for this, when we're just kind of getting into our developments again, it's going to help us here. Now I've just added a little bit of colour on a couple of those surfaces. Sometimes it just helps with visualising what's happening. I need to just get more points of contact in here. Now there's two more that are very evident to me. The one that I constructed earlier, right there, is a POC. And this one here, where it hits the back surface, I think that'll be the forgotten one. That would be the forgotten one in this exam question here, but that's also a POC. I'd like to take those two over onto my elevation. So at least right now I have 1, 2, 3, 4, 5 on the elevation. I'd like to get my full 7 on there. Now what we'll find is that this POC right here is on the center. That's where it hits the back of the object. POC. If I just grab the pencil, well, where is this one? This POC right here. Well, So the part we need to think about now is, where would it be along that line? It's on the blue surface. It's the point of contact that the sphere makes, as the sphere is in here in the center of the object, the point of contact that that sphere makes with the blue surface out here someplace. And I think that the way you have to really think about this is, where is the sphere at its biggest? Because it can't be in contact over here, where the sphere isn't very large, because over here the sphere is at its kind of closest point to us. So the point of contact is always going to be on the closest point to us. It can't be where the sphere appears to be much smaller, like out here. That means that right there is going to be the POC. Now, your drawing is going to be ruined with pink marks if you use pink. I want to make it stand out here for the camera so that you can see it at home. The next thing then we're kind of thinking is, right, where is this sphere right here just dropped into the object? Where does it touch the orange and the green and basically all of the faces all around? We need our 5 points of contact. And once again, my rule there that I had a minute ago still stands. As we look at this view right here, this is right here is the closest point to us with the sphere. It is furthest out, furthest away from the page, and closest to the person looking at it at this point here. So along this line is where it's going to be touching the surfaces of the object. I'm going to extend on that line right up, and I'm going to project my points from the elevation across. What we'll see as well is that the points of contact, because it's symmetrical, they will all happen to line up with each other. So I get at that point and at that point, I get 2 points of contacts each. So POC, I'm just going to write down X2, and this one here is POC X2. So 2 points of contact at each of those points. One for the orange surface here to the front, and one for the yellow one to the back. One for the green surface here to the front, and one for the purple one here at the back. Back to the question. Draw the given views. Done. Show the projections of all points of contact between the ball and the surfaces. Have we 14 points of contact? So we have 2, 4, 5, we've only 6 here. I forgot one. The one on the ground, where it goes down and hits the base of the object right there. So very important. I'd completely forgotten that one. Very important to go back and check your work. Go back and read the question. Tick off as you go. Show the projections of all points of contact. So we have 2, 4, 5, 6, 7, and we have 1, 2, 3, 4, 5, 6, 7. Perfect. Show the projections of all points of contact. The ball with all the surfaces of the container. Tick it off. Draw the complete surface development of the container. This is not bad. This is actually one of the easier developments that has come up over the years. What we'll find is this. There is no cone. There is no conical development, or there is no pyramids. So it is actually quite an easy development. And what would make this even easier is if we saw it the way we're used to seeing it. And if we saw it the way we're used to seeing it, and we stood it up and put it on the XY line, and we use our stretch out line, then we'll fly through this. But it's just, it's just a tiny little step or a change of difficulty, really. It's not even a step up, I suppose. But this right here is our stretch out line. So I'm going to give myself plenty of space for this. That right there is my stretch out line. So I'm going to note that down here. STRETCHOUT line. That's my stretch out line for the development. So it's all going to pull straight down along my page to create the development. I'm going to leave a little bit of space between the views there, between the end elevation. I'm just going to go with, I'll keep it small. I'm not sure how big this is. I'll just go with 5 mil there for now. And that's going to be my starting point, or my seam edge. As we look at the object, and I think that, again, the 3D little sketch of this, which I'd encourage everyone to do at home, it might help us to recognize what is the shortest seam. So we're going to start off by unfolding the 5 sloped surfaces here. Then we'll add on the flat back surface, and then we'll add on this 60-degree front surface. We'll start off though with the orange, green, brown, purple and yellow. The shortest seam possible is definitely not here in the ground, because that's a long one. That's a long one. This one here in the middle is also quite long. It's a bit shorter than the base ones, but the shortest one is up here at the top. So the shortest seam is at the top of the object at the intersection between orange and yellow. So that's what I'm going to get going with now. I'll take that seam. It's a true length. We can see it as a point view. It's a true length already. I can just take it straight down, drop it there, and that's the first line on my development. We want to unfold this object, and as always with developments, we want to be able to see the inside of the object. So I cannot put the orange surface down first. If the orange surface goes down first and the green next, that means I'm looking at the outside of the object. If I unfold this guy up here, and then this purple unfolds down here, and the brown unfolds down here, well, I'm looking at the inside of the object. So yellow surface comes first. I'm going to do my numbering starting at point 1, which is here, around to point 2, 3, 4, and 5. And of course, I won't forget when I go from 1 to 2, 3, 4, and 5, I need to go back to 1. I need my orange surface in there as well. I can see the circumference of the object, and I can see the true length of all of those surfaces in my elevation. Every surface appears as an edge view in the elevation. The distance from point 1 to 2 is a true length. 2 to 3 is the same. 3 to 4, 4 to 5, and 5 back to 1. So I'm going to map them all out in one go. 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 back to 1. 1, 2, 3, 4, 5, and back to 1 again. Before I do anything else, I'm going to make sure I start off and finish up with the same line. That has to be glued back together, or it has to be fabricated back, welded back together. What else? Whatever method would be used depending on the material, but that seam right there, that seam edge and that seam edge, SEAM, have to go back together, which means they have to be the same length. Next, what I'm looking for is the other surface right here. As I said, I'm going to unfold that other surface up here. The second edge of the other surface is referenced the same length as the orange surface. Before I do any of this, I might just take all of my points that I have found down here, and I might just project them across nice and light. That's the orange and the yellow, which, if I wanted to make this nice and fast, it's 2 and 5. 2 and 5 are here. I can project it down. 3 and 4 are here. And there we have it. We have point 2, 3, 4, 5, and back to 1. I'm going to join all of these with a solid line, except just one space. I'm just going to join that. I'm going to skip the center space for now. I'm going to join that, and I'm going to join that. I'm also going to just rub out the line here between 3 and 4, just to lighten that off just that little bit. Now, what I can now do is I can put in my line types here for the 1, 2, 3, 4 lines there in the center. Those lines are not going to be cut after they're going to be folded, so you draw them as a fold line. There we get one. 2 fold lines. Three. Four in there. The back surface of this guy, I'm going to go heavy from 1 down through 2, 3, and from 4, 5, and 6. Why have I left the space there? Well, that space is going to be where I put the back of the object on and that front surface on. I need to attach those surfaces now. The easier surface I think to put on maybe is just a regular pentagon, which is the back surface of the object. So I need a regular pentagon to sit in here attached to 3 and 4. If we just imagine this up here in the main elevation, well, it's just this exact shape that we have right here. The regular pentagon that goes from 3 to 2, 1, 5, 4. So 3 to 2 to 1 to 5 to 4. There's any amount of ways of drawing this. You can get your protractor and set off your 72 degrees. I'm not going to. I'm going to use a much faster method for doing this, using only my compass. I'm going to go from 3 and I'm going to search for 2. So the purpose of my first part of the drawing is to find point 2. So I take the distance from 3 to 2 and I strike it. And I'll also take the distance from 4 to 2 and I'll strike it from 4 to 2. And that gives me point 2. That is called triangulation. We'd have seen that already in class, but there we are. We have 2 fixed points and we go searching for a third point and we get it. That's point 2. If I wanted to find point 5, I have a distance from 4 to 5 and I have a distance from 3 to 5. So let's just see how that looks. So 4 to 5, 4 to 5. I assume it's coming out this direction someplace, but just to tie it down to a position, I need the distance from 3 to 5. 3 to 5 goes from 3 to 5. And where those two arcs intersect, give me 0.5 and I can join the dots. What's left? Point 1, point 2 to point 1. And of course that's the same as 0.5 to point 1. Where those arcs intersect, once again, is point 1, 2, join to 1, 5, join to 1. Oops. And that edge right there, the reason I left it out, that has to be a fold. There's a fold line dropped in there for that one as well. Last surface. I need to get this blue slope surface on. I think we probably know at this stage that's going to be a fold line, so I'll just drop it in as a fold line. The question is, how do we do it? Now the first thing we know is that it's the same width. It's the exact same width. We're looking in at the front of the object. The distance from 3 to 4 is the very same on the grey surface here at the back, and I might just shade that guy in, and even though we are looking at the inside of the object, I'm going to assume that these surfaces are shaded inside and outside. So I'll just get that guy shaded in. That's the regular pentagon that sits on the back of this development of this snooker ball holder. So that's the back surface of the object, but what we need to notice here is that the back and front surface in this view appear the same, even though the front surface, the blue one, is cut and it's much longer. The widths of 5 and 2 are the exact same. So I can make life nice and easy for myself by bringing 5 across, bringing 2 across, and bringing 1 across. So 2 is still going to be here someplace, 1 is still going to be here someplace, and 5 is still going to be out here. And we'll just get this elongated version of a pentagon. The really, really handy part of this is this. When I view my end elevation right here, I'm seeing this line, the line 3 and 4, as a point right there. Okay, so I'll just put a little note on that. Point view of line 3 to 4. If I can see a point view of a line, I can basically put hinges at that point, and I can hinge this guy around, and I can catch it like this and bring it across and swing it and drop it on the ground. And the other point I will need is this one right here, where it gives me 2 and 5. Bring it, swing it, and drop it on the ground. From that grounded position, I have just found myself the distance out to 2 and 5, and the distance out to the top point there, number 1. That's 1. Down to 5, to 4. It's already going across to 3. 3 and 2 joined, and 2 back up to 1. I'm going to pause the video for a few seconds now and add a little bit of colour onto each of those surfaces. And once again, even though I'm looking at the inside surfaces of the object, I'm going to assume that they are same colour surfaces inside and outside. Now I've all surfaces coloured in there just to be able to reference between the views and see what we were linking with what. Bringing it back to my main drawing at the start, and just to add a little bit of colour, so between 1 and 2 was along here, between 2 and 3 there's this purple surface that takes us down here to ground. From 3 to 4 was this very light brown surface along here. 4 to 5 was my green surface up along here. And the final one was my orange surface from 5, bringing us back up to point 1. If you're unsure whether your development is correct or not, then there's one really nice way of just testing yourself out and seeing if you were accurate or seeing if you've put it together correctly. Cut it out. If you cut along all of the outer edges of this guy right here and fold it along all your fold lines and try and make the object, you will see straight away whether you were right or not. You're going to know immediately if it goes together and if it goes together accurately, or if you've made a big mistake and if this blue surface is completely wrong or something like that, you will find out. So that is 2003 higher level question 4. There's the solution to it. A nice developments question there with a good bit in there about points of contact, normals and tangents as well. I hope this video helps. Thanks very much for watching.